ID is red. That means it's important. Okay? That means it's the partition key. It means we can query by it. All right? So again, staff name is purple, which the developers of Cassandra have deemed as unimportant because we can't query by any of the purple things. We can actually use Spark to load the table. This is an IDD. Think nothing's happened here. We're not loading the whole thing into memory. And then because we've got this save to Cassandra thing, we can load it from the customer events table and save it right back into the staff table, which is the same data, just keyed differently. We could run that, and boom, we'd have another table. The important difference is the fact that the staff name is now red, so we can now query by staff name. Now that's not exciting with 3 events, okay? But if you have a large Cassandra cluster, what this will actually do is the Spark worker sitting on each of the nodes will get the events that are local on its machine, take them out and save them back in. So you would not be transferring your data across the network at all, as far as Spark's concerned. Cassandra would then replicate it, however many times you've asked it to replicate it. But so if you've ever got stuck in like a denormalization kind of trap, then Spark's amazing. Even if you've done the same with a relational database, having sharded, you could use Spark to do this. The last thing we're going to show, actually, 2 more things, is report generation. So we've picked Cassandra because we need the 10,000 and 20,000 TPS. We need to be able to scale it. But managers still like reports, right? They like asking questions, they like numbers, they like tops and bottoms and things like that. And there's no way you could do that in Cassandra. You would have to write large amounts of code to take it out. It would not be fun. But you can guess you can do it with Spark. Okay, so what you can actually run on top of Spark is Spark SQL. So what we can do here is, this is normal SQL, right? We can suddenly do everything. Now this isn't going to be quick. I'm not going to back my website by this. This is because I was talking before about how we do things locally on the Cassandra nodes. Group by you can't do locally, that will have to shuffle data. But if you needed a daily report, then you could do this once a day, and it might take a few minutes, but that's fine for a report. So Lambda, someone's already mentioned Lambda, so I'll go for it too. Sometimes you're not going to wait for that report, okay? You're not going to wait for the end of the day to see what's happened. So stream processing came around, and we're like, oh, we'll work something out kind of quick, and then we'll make sure it's right later with batch processing. And typically you'd use 2 completely different technology stacks for that. You might use Storm for stream processing, you might use MapReduce for the batch analytics at the end of the day. One thing I really like about Spark is you can use it for both, with the same API. So I've got a 3rd word count. Have you ever been to a talk with 3 word counts? You have now. So what this word count is going to do is it's actually going to open up a socket, okay? So it's actually going to receive the lines over a socket rather than from a static file. As the lines come in, we're going to run the exact same code, the flat map, the reduce. You're really getting sick of those 3 lines, I imagine. But the difference is we're doing this with what's called the Spark streaming context, right? So that basically means this code is essentially going to execute every 5 seconds. Then every 5 seconds, we're going to persist it to Cassandra. And the massive advantage of this is we could actually have our website, our dashboard, reading directly from Cassandra. So even this is happening in the background, the stream processing, and your website could be built from the tables it builds in Cassandra. Let's see how that looks. So I've used netcat here to just fire in a couple of lines. So I've got Cassandra, 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 and the typo, don't forget Spark, right? What we'd end up with here, this is the first line, okay? Because we still want to store the raw data for doing analytics, batch analytics on it later. So the first line saves the direct things to Cassandra. So we've still got the raw data, we haven't lost that. However, the other bit starts building up these. So we have another table, which is the second bit of code, which is slowly going to build up the numbers, okay? And we can read that and build a dashboard from it. So that's it, 20 minutes. That's a big topic for 20 minutes. But essentially, what I think to take away from this is Cassandra is still an operational database. Don't go build a big analytics system like if you have no operation side. I like to talk about Cassandra and Spark when you're already going to use Cassandra, right? You've already got all that data in there, but you don't want to pull it out just to do some simple-ish analytics. Or you're doing stream processing. Done. So
if I run Spark worker on a Cassandra node for a production environment, which kind of machines do I need? I think I need a machine with a lot of memory there.
Reasonable amount. So I would say the bare minimum I would run a Cassandra node on would be something with, say, 16 gigs. And you would want at least that again for Spark, but it depends on your dataset sizes. You know, Spark will spill over to disk, so it's how fast you want it to be. And you need to make sure they don't run over each other, so Spark doesn't take all the resources of Cassandra, does it? Any more questions? Yeah.
You mentioned a couple of times that I'm not sure exactly who takes care of asynchronous replication of the data.
So that's like core Cassandra. So when you write to Cassandra, one of the things you tell it is how many replicas I want in each of my data centers. So that's going to happen regardless of how you write it. I'm going to say I want 3 replicas in my operational system because I want fault tolerance and all this stuff. Maybe I'll have 1 replica in my analytics system because I'm cheap and I don't want to buy 2 disks. Okay? When you're actually doing the writes, you get to decide how slow you want the write to be. So you can say, I'm going to wait for 1 node to get, or all of them. And you're really just there trading off consistency versus latency. Any more questions? If you think of questions later, you can email me or send me on Twitter, no problems, yeah?
You lost me on the example with the conversion from the customer ID to the staff name. You said you're not going to rewrite or move any of the data. But if the data is partitioned by the key, which is the customer ID in the first case and the staff name in the second case, you'd have to move data.
Yeah, so if you didn't hear that, the question was, I said Spark doesn't move any data. We're not doing any shuffling of the data in Spark, or if it was, say, MapReduce. And we're going to read it from the local Cassandra node at consistency 1, and we're going to write it back at consistency 1. But yes, in the background, that data will be replicated wherever it needs to go. But that's the bare minimum data transfer you'd ever need. Any more questions? If you've got any, just ping me on Twitter if you need any questions about Cassandra. It's kind of my job. Or if it's a really, really long question, ping me and ask for my email. Thanks, everyone.